right, today we are going to review powers and exponents. Okay, you don't have to write down the next part of it, but write down the title. By the end of today's lesson, you guys should be able to evaluate powers, write powers in different forms, and determine if a number is a perfect square. Okay, so the first thing that we need to talk about is what a power is. Okay, a power is the result of a repeated multiplication of the same factor. The same factor means the same numbers being multiplied together. So, for example, look at this problem over here. Right here, that is red. Notice it's a big 5 and a little 4. That is red 5 to the 4th power. Okay? And what that means, that doesn't mean take 5 times 4. It means this number 5 right here, the bigger number, that's what we call the base. And when it has a base of 5, that is the number, the factor that is multiplied by itself. Now the little 4 up here is what we call the exponent. And the exponent of 4 means you are going to multiply 5 by itself 4 times. So you basically write down 4 5s. So that means it's 5 times 5 times 5 times 5. That's exactly what that means. So you're going to have to know how to write not only as an exponent or as a power, but written out as a repeated multiplication problem. Now, when it says find the value, that means you evaluate, which means find an answer. But before we can do that, we need to know some special ones. Math is really special, but these are extra special. See how the exponent on this one, that's 3 to the 2nd power. That has a special name, and it's said 3 squared. Okay, and what happened is that came from a square. Look over at my square here. We know in a square that it has 4 90-degree angles, and on a square, all the sides are the same. So when I put one hash mark on there, that means all sides are the same. Well, if this one's S, then that one has to be S. And when you find, so does this one, and so does this one. When you find the area of a square, it's length times width, but in this problem, it's S times S. But isn't that the same number, factor, written down twice? So we write that as S to the 2nd power, which is called S squared. Look at the next one. This one says 4 to the 3rd power, but that exponent of 3 is called cubed. We say it cubed. Well, it came from a cube. If you look at that cube, we know a cube is like a die. All the edges are the same. They're made, the faces are all squares. If I asked you to find the volume of that, the formula for volume is length times width times height, which is how much it holds. But in this case, look at each edge is the same. So it would be side times side times side. That's the same factor written down 3 times. So it's side cubed. You guys always need to remember that in the area of a square, the units are always units squared. When it's volume of a cube, it's units cubed because it came from a cube. All right, so some of the directions that you're going to see, it's going to say write the product as a power. Well, look at this one, number 1. Write it down in your notes. 6 times 6 times 6. That's the same number written down 3 times, so that's your base. How many of them do we have? 3, so that means 6 to the 3rd power. Okay, number 2 says 13 times 13. That's the same factor, so we're going to write down 13 squared, or 13 to the 2nd power. All right. Number 3, I want you to do number 3. Okay, and bring that back tomorrow. I snuck in this 3.5 problem. This is important because do you see how these are -2 times -2 times -2 times -2? Whenever you have a negative number or whenever you have a decimal or a fraction, you always want to put them in parentheses. You want to put the base in parentheses. So we're going to write -2. And how many of them are there? 1, 2, 3, 4. So that's to the 4th power. Okay? And the next one says find the value. That means find an answer. But what I want to do to make sure I get the correct answer, write down number 4. It says 2 to the 4th power. We always get super excited about doing this in math. And you say 2 to the 4th power is 2 times 4. That's not what it means. It means take 2 times 2 times 2 times itself 4 times. Now we're going to find an answer. 2 times 2 is 4. This 2 times 2 is 4. 4 times 4 is 16. Okay? Number 5, when I write that down, 14 squared, what does that mean? It means take 14 times 14. And when you do that, you go off and you take 14 times 14. That's 16, that's 5, 0, 4, 1. You get 196. That's evaluating it. Look at number 6. If you notice, 10 does not have an exponent on it. If you don't see the exponent, it's automatically a 1. 10 to the 1st power is just 10 times itself. Just 10. That's the answer. 10 squared, or 10 to the 2nd power, takes 10 times 10. These are mental math. That's 100. 10 to the 3rd power means take 10 times 10 times 10. The easy way to get this answer, write down the 1 and put however many zeros you have on there, which is 3, and that's the same as the exponent. So that's really 1,000. So if I look at 10 to the 4th power, all I do is put a 1 and 4 zeros. 1, 2, 3, 4, and I get 10,000. 10 to the 5th would be a 1 with 5 zeros. Okay? So next thing we need to talk about are perfect squares. Perfect squares, it's the square, which is the 2nd power, right, of a whole number. So the exponent has to be 2. Are they perfect squares? Well, let's list perfect squares, meaning 1 times 1. 1 times 1, 1 squared is 1 times 1, which is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6 is 36. 7 squared is 49. 8 squared is 81. Oh, sorry, my bad. How about 64, Mrs. Bowen? Duh. 9 squared, here we go, 81. 10 squared. 10 squared, 100. 11 squared. You're going to have to memorize these. 121. 12 squared, 144. 13 squared is 169. And it keeps going on and on and on. Okay? So we have to determine, are these perfect squares? So look at this one. It says, is 47 a perfect square? Well, is there something times itself that gives you 47? Look at that list of numbers that we just did. These are all called perfect squares. These numbers here, something times itself. Do you see 47 in there? It's in there. It's not on the list. So is 47 a perfect square? No. What about 36? Is 36 a perfect square? Well, look, you see it right there. That means, yes, it is, because it came from 6 times 6. What about 121? Look on your list. Oh, there it is. That would be another yes. All right, you guys, I want you to try these 6 problems, and they go into your notebooks as well as the rest of the notes. Alrighty, so tell me, why doesn't anybody talk to circles? Why doesn't anybody talk to circles? Because there's no point. You remember circles are round, so it has no point. Oh, goodness. They don't have any sides that come together. Bring these back tomorrow.